Hey guys, we're going to do part two of the research methods part. I'm going to try and keep these somewhat simple because I think a lot of this stuff is probably better served to be explained in class a little more, which we're going to do. But I want to make sure that you have sort of a background information before we get into any of this deep statistical stuff. Um, we're not going to have to do, or at least for the AP exam, you're not going to have to do a lot of hard technical math. Most of it is very basic um, things that you can do with on a scratch sheet of paper or something like that. So don't freak out about the math part that I'm getting ready to show you. A lot of it sounds complicated, but when we talk about it in class, it should clear up a little bit some of the ideas. It is statistics, but that's really how we explain some of the things that we see when we're doing studies. So, but I'm going to lead off tonight or today, this eclipse day. I'm making this video after the eclipse. We're going to start out with correlation, all right, which is basically just a great big word for relationships. All right, is there a relationship between this thing and that thing? All right, and the example that I have on the screen is ice cream and murder. All right, which may seem odd. As more ice cream is eaten, more people are murdered. All right, that is a correlation. They are related, but one thing you got to remember is that correlation does not show causation. Just because they're related does not mean one caused the other one. Does ice cream cause murder, or murder cause people to eat ice cream? Common sense tells us that that's not the case. Another example might hit a little more close to home is trucks and people named Bubba. The more people, what's a good way to put this? If your name is Bubba, you are more likely to drive a truck. There's not a whole lot of Bubbas out there driving little Toyota Priuses. Okay, there's a correlation there. More Bubbas drive trucks than Priuses. But is there a causation there? Just because your name is Bubba, does that make you drive a truck? No. So we got to be careful to make sure that make sure we know what we're talking about. Correlation, just because there's a relationship there, does not necessarily mean that there is causation. Okay? Then that's sort of the big thing. Those are going to be two terms I want to make sure you all know on your flashcards is the difference between correlation, or relationship, and causation, where there's an actual A causes B. And there are a few different types of correlation. There's positive correlation and negative correlation. All right, and this is kind of a graphing type thing, but essentially the variables in positive correlation go in the same direction. An example might be studying. The more time you spend studying, the higher the grade. So if you're graphing this, a bunch of different plots, what you'll see is the more time you spend studying, the higher your grade is. All right? Or the other way, the less time you spend studying, the less your grade is. All right? Because it doesn't matter if on the graph you're going positive or in the negative position. You're looking at if the variables are going in the same direction. That means there is a positive correlation. Whether it goes up or down, it's positive. They're both the same. Negative correlation. If positive correlation means they're going the same direction, what do you think the negative correlation means that the variables are going? Hopefully, you said different directions. All right. For example, heroin use and grades probably has a negative correlation. the higher the heroin use, the lower the grades. Does that make sense? If this area right here is a graph and we're doing X, Y, the more heroin you use, all right, the lower your grade's going to be. They're going in opposite directions, which means there is a negative correlation there. There's still correlation, and remember, we're not talking about causation. We're talking about correlations. But that's sort of the difference, and you're going to need to know the difference between positive correlation and negative correlation. The correlation coefficient was just a fancy word for how strong is the relationship. And so you can actually measure how strong the relationship is between the amount of studying you do and your grades. All right, you can actually plot that and say, wow, that's a very strong correlation, or it's a very weak correlation. Now, the stronger the correlation is, you're going to be closer to saying there may be some causation there. It's different, okay? But the correlation coefficient measures how strong the relationship is, either positive or negative. And this is going to range from -1 to 1. And here's your positive and negative again. So if you've got and that's the highest it's going to go, is -1 or 1. So again, think of this as a number line, where a -1 is as strong of a relationship as you can get in the negative side, meaning they're different. The variables go different ways. Higher heroin, lower grades. To +1, higher the studying, or more studying, the higher the grades. They're going in the same direction. So -1 to 1, when you see this statistically, are going to be as strong as you can get, which makes sense because if the correlation coefficient is 0, what does that tell you about the strength of the relationship? Is it strong or is it weak? Hopefully you said weak. Think of 0 as 0. It means there's no strength. So, and that's, again, if you can think about this on a number line, that may make a little more sense, with 0 being the least amount of strength, +1 being a positive correlation, as strong as it can get, or -1 being a negative correlation, as strong as it can get. Yeah, the relationship gets weaker the closer you get to 0. Take a look at these. Which correlation is stronger? -0.3 or +3.8? Which one is further away from 0? +0.38. That is a stronger correlation. Look at this one. -0.72 or +0.59. Which is furthest away from 0? -0.72. All right, it's closer to 1. It's further away from 0 if you plot it on a number line. -0.91 or +0.04. All right, that one's pretty easy. 0.91 is almost as far away from 0 as you can get. So, again, we'll go over this a little more in class, but these are just some of the basic things with correlation and correlation coefficient, stuff like that. All right, now we're going to talk about some of the different methods that we use in getting information as budding psychologists. The first one that we're going to talk about here, which is probably the most widely used, is the survey method. The assignment I gave you about getting set up or participating in a research project, the majority of them are going to be surveys. So again, this is an easy way to get this, get involved in a psychology project, but also kind of see what's going on. But in this, the survey method is one of the easiest. I'm gonna have to plug in here in a minute. The most common again, the most common type of study in psychology, and these try to measure correlation. All right, so you're looking to see where there are relationships. All right, and it's cheap and it's fast in most cases. Apologize as I try and get this plugged in and try to not do much. But in order for this to work, you really need to have a good random sample. All right, so your sample obviously has to represent a good part of, or has to do well with representing your population. Excuse me while I plug this in. And it has to be random. Meaning everybody has to have an equal chance of being a part of it. There we go. Now we're plugged in, ready to roll. So, but that's survey method. Those are easy to do. It's just questions. You get those all the time for different things, but psychologists use these as a way to sort of see if there are relationships between two different whatever variables that they're studying. One of the issues with this is that a lot of times you get a low response rate, meaning to take a survey, you have to take time out of your day. You've got to read, fully answer questions, and a lot of times people just don't have the time or you want to put the effort into it. So, and that's one of the drawbacks of doing a survey. And then the other part of it is one of the things we talked about during the last section is the Hawthorne effect, where if people know they're being studied, they may change their behavior. So they may give the survey or the researcher what they want to hear instead of what they really do. And again, this can be a confounding variable, one of the things we talked about in the last session. But it's still, still one of the it's still a decent way to get information if you're trying to. This next one is called naturalistic observation, and it's just what it says. You're observing things or people or whatever. Generally, it's people in their natural habitat, meaning you do not manipulate anything about the scenario. You just watch. And you all are actually going to be doing a couple assignments on this week and next week, so hopefully you pay attention real close to this part here. But the idea, again, watch subjects in their natural environment. You do not manipulate the environment. Again, it's just observation. And this is good because there is a Hawthorne effect. If people don't know you're watching, they're not going to change their how they act. The problem with this is because you can't manipulate the environment, there's no a way to show cause and effect. Because there's so many other variables, it would be very difficult in just naturalistic observation to actually say A causes B. To see this right here, it'd be very difficult for us to say women who wear overalls cause men in overalls to be attracted to them. It doesn't. Number one, that doesn't make sense. But two, there's no way to cause that, or there's no way to see that because we can't manipulate that. We can't use a different guy and see if he's attracted to her. We can't really dress her up differently to see if that changes any of the attraction from the dude. So we're just kind of left with what we can describe. Now, we can learn a lot from this, but one thing we cannot do is show cause and effect. Another way to get information is case studies. These are a detailed picture of one or a few studies. You all remember the John and Kate, I think it was +8. They were a pretty good case study in a lot of different things. I mean, is that 8? 1, 2, 3, 4, 5, 6. Yeah. So just because this is a different dynamic than most families here in this country. So to be studied real closely. The thing about case studies, though, is all it would tell us a story. It's just descriptive, meaning we still can't get any correlational data. We don't know any relationships going on other than what we see, and you don't always see everything. So, case studies again are useful. They give you some in-depth, very descriptive research, but case studies again are not very useful if you're looking for correlation or if variable A is related to variable B. And I don't know what that would be in the whatever TV show that was. So those are some of the, I think we went over a few earlier in the previous session, but those were a few of the different ways which we get the information that we get as psychologists. Now, how do we report those? How do we explain those? Well, that is statistics. And this is really how we record our results from what we're studying. So if I gave you an assignment to study the effect of, let's say, grab and go on grades versus no grab and go and grades, and you would have to, come up with some statistics. You'd have to do a study or do an experiment. Then you'd have to record the data. Then you'd have to present that data using statistics. And the reason why we use statistics is because it is a common language. I mean, stats are pretty much the same across the board. It doesn't matter what form of science you're looking at. And again, these statistics, these quantifiable numbers, is what makes psychology a science and not a pseudoscience. So as much as boring as they can be, the statistics part really tells us what we're seeing, and it's what makes psychology a science. First type of statistics we're going to hit is descriptive. Again, this just describes two sets of data. This could be a frequency distribution, meaning how often something occurs within a period of time. And there are different ways to show that. Generally with graphs like this, either line graphs or bar graphs, maybe even some scatter plots, which we're going to talk about in a minute. But these just describe the data. It gives you a visual of what we're looking at. This right here is if these two were two different variables, all right, then this would be a positive correlation because they're both going up. Or I'm sorry, they're both going the same direction. I don't want to confuse you. I just confused myself. Because they're both going in the same direction, okay, that makes it a positive correlation. Central tendency, and this is basic math things, especially in you Algebra 1 people. This should be pretty, you should know what this is: mean, median, and mode. This describes how your data is grouped. Mean, of course, is the average of your data set. Median is if you put your data set in numerical order. It's the very middle number. Think median in your road, or a median. Going down the bypass. You've got, I think now it's a left-hand turn lane, but it's also the median, meaning it's in the middle of the road. And then mode is the number of data points that are the same. So you may have, if we're doing the central tendency of the ages in our class, we would have probably a whole bunch of 14s and 15s, and maybe a few 16s, but the mode is probably going to be 14 or 15, depending on how many freshmen we have. So, but the mode is just how many times a number is repeated. Again, median is the middle number, and mean is the average. What you'll find is in a lot of my tests, when I create a question, I tend to use people's names who are from The Office TV show because I think it's funny. Um, but here's sort of an example that we're using to look at central tendency and data points using the Dunder Mifflin Paper Company. What this data set here is the salaries, and I don't think this is probably true, but this is just an example. All right, so you've got three people, Pam, Kevin, and Angela, who all make $25,000 a year. Pam is a receptionist. Kevin and Angela are the accountants. You've got Andy, Dwight, and Jim, who are the salesmen. They make, who are Andy and Dwight, who are the salesmen, the junior who make $100,000 a year. You've got Jim, who is the number 2 in the office, make $200,000, and Michael, the branch manager, Michael Scott, makes $300,000 a year. Now, based on the television show, that is not the case, but just for the purpose of this example, we have a data set. So this is our data set that we're going to use. So if we were doing some statistics on this to find the mean, median, and mode, we would add all these. We'd find the average. That's the mean. We'd add them all up and find the average. And I'm not going to do that for you. Oh, yeah, I will. I should have had this already brought up. Let's find my calculator. There it is. All right. So let's find this real quick. 25,000 plus 25,000. And why don't you all do this while I'm doing it too? Plus 25,000 plus 100,000. Is that right? Yeah. Plus 100,000 plus 200,000 plus 300,000 equals 7,750 or 775,000. I don't teach math. 775,000 divided by 1, 2, 3, 4, 5, 6, 7 divided by 7 equals $110,714.28.5. We'll round that up to 29 cents. All right, so that is your average. That's the average salary for the people who work at Dunder Mifflin. If these were correct, which I don't think they are. But there you go, 110. So let's bring the PowerPoint back up. Median salary. Okay, so I've already done the mean. So, but remember, median is the middle. So there's 1, 2, 3, 4, 5, 6, 7. So if we use the middle one right here, 3 above, 3 below, that would be Andy at $100,000. So this would be your median, and then your mode would be the one that here's the mean. We've already done the mean, 110, and the mode is only 25,000 because you've got 3 of those. All right. So when you're looking at central tendency, how much your data sets are close versus spread out over the number line, you want things to be close. And when you've got a mode that is quite a bit different than your mean and your median, you don't have as high a central tendency. And I'll show you what I mean by that right here. This is a normal distribution. This is what you want to see right here. This is a bell curve. This is what's known as a bell curve. You've got your median. The line right here is the median. Basically, your mean. your median, and your mode are going to be all the same. So your average, your very middle data set or data point, and the highest number of data points are all going to be in the exactly the same. That creates this little bell curve. And the idea is you're going to have 50% above and 50% below. And this is what you want to see. Now, we don't always see this, but this is going to be useful from here on out, and especially for you freshmen. Get to know and get to love the bell curve. All right. When you have a lot of outliers, like in the Dunder Mifflin example, remember we had 3 people who made 25,000. That sort of skewed the distribution a little bit. So with that distribution, you're not going to have this. You're not going to have this right here. You're going to have a few more on the lower side. So you're more than likely to have a negatively skewed distribution. So your 25,000 points are going to be mentioned here through your data set, and then everything's going to catch up. But that will shift your bell curve. If a group has one high score and the curve has a positive skew, or it contains more low scores, is positively skewed. If your group has a low outlier, one low outlier, the curve has a negative skew, contains more high scores. There are a few other measures of variability. Range, again, these are all things these are essentially going to be terms you're going to have to do your flashcards on. But range, when you're looking at a data set, it's going to be the distance from the highest to lowest. So in our Dunder Mifflin example, the range is going to be 25,000 to 300,000. That's your range. Standard deviation is it's going to be hard to explain on this. We'll probably do more of that in class. But as a definition for your flashcards, you're going to want to put, essentially, it's the variance of scores around the mean. In layman's terms, it's how far away each score is from the mean. So again, if our mean with the Dunder Mifflin example was 100,000, and let's look at Jim's score. All right, we're gonna trying to figure out the best way to. It'd be easier to explain it in class, but basically, there's a statistical formula where we're going to put in to show what 33% is of that above the mean, and then it kind of goes up from there. It makes more sense when you see it in class. I'm not going to try and explain it on this because I think I'm running out of time too. Trying to keep these short. Big thing to know is that the higher the standard deviation, the more spread out the distribution is. If you've got a standard deviation of, let's just look at IQ. The standard IQ in adults, the average is the median is 100. Well, in IQ tests, and I can't remember which one, the standard deviation is 15. So you're going to have 33%, actually you're going to have 50% above, 50% below that mean, but you're going to have 64% within one standard deviation. Again, you're not going to understand that until we start until I show you really what that means. But all it is describing how spread out your data set is. An example here, I've got Stephen Curry and Kevin Durant. They both might score 25 points per game. They in fact they do have the same mean, but their standard deviation is going to be very different. Curry has a tendency to be a bit more. Most of his games, if you go back through his stats, are going to be somewhere around 25. Whereas Kevin Durant, he may have a game where he blows up for 100, and then may have 3 or 4 games where he only scores 4 or 8 or something like that. Kevin Durant's standard deviation is going to be much larger because his data points are spread out. He's got 2 or 3 at 8 and like maybe 1 at 100, or not 100, but you know what I mean. So his data points are going to be spread out, whereas Stephen Curry's is going to be right around that 20 to 30 points per game range. So again, maybe that's a little better way to explain that, what the measure of variability is. Now, let's think about this. I know I've not explained it great, but if you're a scientist, do you want a big standard deviation or a small standard deviation? Meaning, do you want a big spread of data, or do you want all your data to kind of say pretty much the same thing? So I'll let you ponder that for a little bit. Z-scores, I'm not going to get into a whole lot right now. That just shows you how far you away from the mean, how far a data point is from the average. If you're a positive score, it means you're above the mean. If negative score, you're below the mean. That's pretty easy. Here's your normal distribution. Again, I'll go over this in class. But again, here's your average. So 50% you've got above, 50% you've got below. And in a normal distribution, you're going to have 68% within one standard deviation on each side. Within 2 standard deviations, you're going to have 95% of your data. And then within 3 standard deviations, you're going to have 98% of your data. And then you'll have the other 2% on the outside of that. So again, I'll explain a little more of that in class. I'm not going to go over inferential statistics because I don't believe they're on the AP exam. I'll double check that. But all that is look at how much of our data points is actually in because of chance as opposed to what the data is actually, what we're hoping to measure. Last thing we're going to talk about real quick is the APA Ethical Guidelines for Research. APA is American Psychology Association. You're going to really get to know them if you write a lot of research papers, or really any papers, because a lot of sciences use the APA form of citing sources. So, but that's a different time and place. This is run by the IRB, or the Internal Review Board. You do need to know this for the AP exam. This is very important because whenever somebody comes up with something they want to study, they have to submit it to the Internal Review Board, and it has to be approved. So in some of the things that's if you're studying both humans and animals. So even if you're doing a research with animals, you've got to send this in. There has been animal research. In order for it to be approved, you've got to have a clear purpose. It's got to be helpful, and they have to be treated in a humane way. You can't lobotomize which means basically destroy a big chunk of the brain of a rat, because it's not very humane anymore. Used to be done quite a bit, but not as much now. You have to get the animals legally. It means you can't go through the black market, which means you can't get hard to find or endangered animals or things like that. If they're hard to find or if they're hard to get, there's probably a reason for that. So in order to cut the mustard, I guess, with the Internal Review Board, you need to be able to get your animals that you are going to study legally. And then they have to go through, if they are going to suffer, you need to at least do the least amount of suffering possible. There's not much animal research done anymore. When we start studying some of these older projects, people were kind of... some of the animals did suffer quite a bit, which is why this was put in there. When you're doing human research, all of the participants must be voluntary. You can't coerce them. Meaning, if I was a psychology professor and I was doing research, I could not mandate that my students participate in one of my experiments. So it has to be voluntary. I can give extra credit or things like that, but it must be voluntary. And you must have informed consent Um, as a researcher, you should not really know who they are. So there needs to be some sort of anonymity, especially in presenting the results. There can't be a significant risk to the human, and you must debrief the person. These are all things when you are taking the AP exam. There have been questions on all of these. They'll give you an example of a research project, and they're going to ask you what's wrong with it, and you're going to have to pick which one of these things is wrong or what didn't happen, and we're going to practice that too. But as you can see, this is sort of the end of the thing or of the PowerPoint. A lot of I know some of it I went over quick, but again, I'm just sort of trying to give you a base for what we're going to talk about in class, and if I can just get this online, then you can go back and relook at it if you're having trouble. But anyways, that's it, and we'll see you all in class.